let's consider this question. Let's find the limit of this function as x tends to pi. To solve this problem, step number 1, apply direct substitution, that is, plug in. That is, wherever I see x, I'm going to put pi. But remember, cos square x is the same thing as cos x all squared. Subsequently, radians are alternate units used to measure angle in trigonometry instead of degrees. Pi is equal to 180. When analyzing an angle, this pi is equal to 180. Hence, pi over 2 is same as 90 degrees, and pi over 4 is the same as 45 degrees. Always remember this. With these concepts in mind, instead of pi, I will now put 180. And cos 180 is minus 1, while sine 180 degrees is 0. And 1 minus 0 is 1. And 1 divided by 1 is 1. And our answer is D. And because we got an answer using step 1, which is plug-in, hence we do not need LHopital rule. Next, consider this question. Step number 1 is to plug in for x. That is, wherever I see x, I will now going to put pi over 4. Pi over 4 is the same thing as 180 over 4 is the same as 45 degrees. Hence, instead of pi over 4, we can now have 45 degrees. Tan 45 is 1, and sine 45 is root 2 over 2. Likewise, cos 45 is root 2 over 2. And here we got 0 over 0, which is undefined. Next, step number 2, we're going to apply LHopital rule. And here we're going to differentiate each of these variables separately. That is, differentiate 1, and we're going to get 0. Next, we're going to differentiate tan x, and we're going to have sec squared x. Next, we're going to differentiate sine x, and we're going to get cos x. Next, we're going to differentiate cos x, and when we differentiate cos x, we're going to get minus sine x, and this will be in a bracket. Next, we're going to rearrange this function and then take the limit as x tends to pi over 4. Minus multiply this minus is going to give you plus. In trigonometric identity, sec square x is the same thing as sec x all squared, and is the same thing as 1 over cos x all squared. Hence, I'm going to use this to replace this at the numerator. Next, we take the limit, that is, wherever I see x, I'm going to replace it with pi over 4. Pi over 4 is the same thing as 45 degrees for a trigonometric function. And sine 45 is the same thing as cos 45, and it's the same thing as root 2 over 2. Next, this squared, we take away this square root, and we are left with 2. And this square, we square 2, and you have 4. This 2, we take away this 2. Next, we are now left with minus 2 divided by root 2. Next, this is not a proper surd. Hence, we're going to rationalize. Next, by rationalization, I will use this square root at the denominator and multiply both the numerator and the denominator. Minus 2 multiply root 2 will give you minus 2 root 2. And root 2 multiply root 2 will give you 2. Remember, root 5 multiply root 5 is 5. Root 3 multiply root 3 is 3. Root a multiply root a is a. And these 2 can now take away these 2. And your final answer is minus root 2. And from the options, our answer is A. Next, let's consider this question. Step number 1, apply direct substitution. That is, wherever I see x, I will input pi over 6. Likewise, pi over 6 is the same thing as 180 divided by 6 and is the same thing as 30 degrees. Hence, instead of pi over 6, I will now have 30 degrees. Sine 30 is 1 over 2, but cos 30 is root 3 over 2. And this will give you 0 over 0, which is undefined. For such indeterminate result, we are going to apply step number 2, which is LHopital rule. That is, we are going to differentiate each of these variables separately. Next, step number 2, apply LHopital rule. Differentiate root 3 sine x, and we have root 3 cos x. Next, we differentiate cos x, and we're going to have minus sine x. This will be in a bracket. Next, differentiate x, and you're going to get 1. Next, differentiate pi over 6, and you have 0, because there is no x to respect. It is a constant, which is 0. Next, I will rearrange the function, then I will take the limit as x tends to pi over 6. Hence, wherever I see x, I will replace it with pi over 6. Likewise, pi over 6 is the same thing as 180 divided by 6, which is 30 degrees. Remember, for a trigonometric function, pi is the same thing as 180 degrees. Sine 30 is 1 over 2, and cos 30 is root 3 over 2. Hence, this will become this, because cos 30 is root 3 over 2 and sine 30 is 1 over 2. If you solve carefully, your answer is 2. Remember that root 3 multiply root 3 will give you 3. And 2 becomes our final answer. And from the options, our answer is D. Next, let's consider this question. Step 1 is by direct substitution. And by plugging, we got 0 over 0. Next, step number 2, we are going to apply LHopital rule. That is, we are going to differentiate each of these variables separately. Differentiate cos x, and we're going to get minus sine x. Next, we're going to differentiate x, and we're going to get 1. Next, we're going to differentiate pi over 2, and we're going to get 0. Next, we take the limit as x tends to pi over 2, and pi over 2 is the same thing as 90 degrees, which is 180 over 2. And minus sine 90 is minus 1, because sine 90 degrees is 1. And from the options, our answer is C. Next, let's consider this question. This is the function, and we're taking the limit as x tends to pi over 2. However, we have a minus here, which is a superscript. The minus just indicates that this limit is approached from the left, and it does not affect the x tends to pi over 2. Hence, we're going to solve this problem as if this is just alone. Step number 1. Apply direct substitution. And by plugging, we got infinity to the power of 0, which is indeterminate. To apply step number 2, let's remember that the natural log of a to the power of b is the same thing as b, the natural log of a. You can see that this b came to the back of the natural log. We are going to apply this to the function. In step number 2, we are going to say let y be equal to the given question. Here, I'm just letting out the superscript because it doesn't change the question or the function. Step number 3, we are going to take the natural log of both sides. Next, in step 4, we are going to take this cos x at the powers and bring it to the back of the natural log. Hence, step number 3 will become this. The cosine is now at the back of the natural log. Step 4 is same as step 5 because cos x is the same thing as 1 divided by 1 over cos x. You can see if I solve this denominator, which is this, I'm going to get cos x back, which is this. Hence, nothing has changed. Subsequently, 1 over cos x is the same thing as sec x. That is, at this denominator, instead of 1 over cos x, I'm going to write sec x, which will be step number 6. Because of this concept, I'm going to rewrite this, and we are going to have 1 over sec x. Next, in step 7, the sec x will continue to divide at the denominator. Next, in step 8, we are going to apply LHopital rule to this function. In step 8, apply LHopital rule. That is, we are going to differentiate each of these functions separately. To apply LHopital rule, let's recap. If you're given y equal to in x to find dy dx, your answer will be, first you need to differentiate the x, and your answer is 1. Next, you will now recopy back this x to the denominator. This becomes your answer. Let's apply the same concept to this question. We are going to differentiate tan x, and our answer is sec squared s. Next, we are going to recopy back the tan to the denominator without the natural log. This becomes our answer. Likewise, if we differentiate sec x, your answer is going to be sec x tan x. With this concept, next let's differentiate the numerator, which is in tan x, and we are going to have sec square x over tan x. Next, we are going to differentiate the denominator, which is sec x, and our answer is sec x tan x. Before we take the limit, let's simplify this further. Next, this and this are the same. However, sec square x is the same thing as 1 over cos square x. Subsequently, tan x is the same thing as sin x over cos x. And sec x is the same thing as 1 over cos x. And tan x is the same thing as sin x over cos x. Next, I will simplify this further. Still simplifying step 8, this and this both are the same. And we are going to change this to a multiplication sign. And it's going to inverse cos to the numerator and sine to the denominator. Next, the division sign changed to multiplication sign. Hence, the cos moved up and the sine now came down, which is this. Next, we are going to change this division sign to multiplication sign, and it's going to inverse this function. Next, we can open up all the brackets, and this cos square x can take away cos square x, and we are now left with cos x divide sin square x. Now that we have simplified step 8, next in step 9 we are going to take the limit of this function, that is the simplified function. Hence, we are going to take the limit of this function, that is, wherever we see x, we are going to input pi over 2. Pi over 2 is equal to 90 degrees, which is 180 divided by 2, which is 90. Cos 90 is 0 and sin 90 is 1. Hence, the natural log of y becomes 0. Next, to make y the subject and get rid of the natural log, we are going to take the exponentials of both sides of the function, which is step 10. Take the exponentials of both sides. Exponential will neutralize natural log. Next, y is now equal to exponential 0, and exponential 0 is 1. Recall from step number 2. We assigned the given question to y. If y is equal to 1 and we assigned y to be equal to the given question, then our final answer is 1. And from the options, our answer is D. Next, consider this question. In trigonometry, pi over 4 is the same thing as 45 degrees. Likewise, sec square x is the same thing as 1 over cos square x. Hence, in the given function, sec square x can now become this. And using this concept in step number 1, which is direct substitution, we are now going to have an indeterminate form of result. Next, Step number 2. Apply LHopital rule. And here we got two options. Either to use difference of two squares, or we can differentiate separately. If we are to use difference of two squares, then we are going to recall a trigonometric function that will help us to solve this problem, which is sec square x is equal to 1 plus tan square x. Hence, instead of sec square x, I will replace it with 1 plus tan square x. With respect to this identity function, 1 minus 2 will give you minus 1. Next, we can apply difference of two squares to this function, because 1 squared is the same thing as 1. Applying difference of two squares, this can take away this. Next, we now take the limit of the remaining function. Taking the limit of the remaining function, our answer is 2. Alternatively, by differentiation, this and this function both are the same. Sec squared x is the same thing as sec x all squared. Differentiate sec x all squared, and your answer is 2 sec x tan x multiply sec x. Next, differentiate 2, and your answer is 0. Next, differentiate tan x, and your answer is sec squared x. Next, differentiate 1, and your answer is 0. Next, sec x is the same thing as 1 over cos x, and tan x is the same thing as sin x over cos x. Sec x is 1 over cos x, and sec square x is the same thing as 1 over cos x all squared. Pi over 4 is the same thing as 45 degrees. Hence, you take the limit of this function. Wherever you see x, you substitute 45 degrees. Substituting and solving carefully, your answer is 2, which is the same as we got earlier. And from the options, our answer is D. Next, complete this question. And if you solve correctly, you are going to get B. Next, complete this question. If you solve correctly, you are going to get D. In PRECALCULUS. To locate all the videos, follow the link on the screen. I will see you in the next video.